Hi. In this video, I'm going to explain about the Nand2tetris project and the logic gate implementations that can be done using the Nand2tetris project. So, project is a computer science educational project, an initiative that is created to teach students how computers work from ground up. So, one of the key components of this project is the implementation of logic gates using only the NAND gate, which is a fundamental building block of digital circuits. The reason why NAND to Tetris logic gates are essential is that they are basic building blocks of all digital circuits. And by using the NAND gate as the only logic gate, we can create more complex logic gates. Uh, and then we can use a combination of lot of simpler logic gates and make more complex logic gates. So to use the Nand2tetris software to implement various logic gates, we first download and install the Nand2tetris software, and which includes a hardware simulator and emulator and assembler and a lot of tools. So first we open the hardware simulator, create a new project, and then in this project we create an HTML file for each logic gate we have to implement, and then we write the HTML code for each file. And after we've written the HTML code, we can load this code into a hardware simulator and test the gates function by inputting various combinations of serial inputs and serial outputs. And you can then use this logic gate to you have implemented as a building block to create more complex circuits. So I'm going to start by showing how this works. So this is the hardware simulator that we use. So since we I've already created this project, and then there's already all these logic gates already implemented. So I will start by doing the AND HDL. I've loaded this chip and.htl. After loading this, I'll go to File and load script for AND. And to check this, I'll click Run. It will compare using the comparing value with the comparing file, and then comparison ended successfully, which means we've successfully evaluated the AND file. Similarly, we will do for AND 16 again. Load script. So this checks for the comparing value, and again successfully done. So in case you might be wondering what might be, so this is the code which is there. So this is the not, for example, this is the not HTL. I've already downloaded this the code, and then there's this part of the code which we have to edit in each of the codes. So since I'm not taking a lot of time on this, uh, this is a kind of a code which is there, which is a basic code which is already given. The parts, after the parts, there will be a comment. You just have to remove that and put your own code. So and then similarly for not or and is all mux tmux, the not 16 and 16 mux 16 or 8-way, and this tmux 4-way. So in this way we have to create the like a similar simulator. We have to create the HTML files, run the simulator files. So I'll just run every one of them just for confirmation purposes. So I think you correct Dmux, right? Yes. So we'll try run Dmux. And as you can see, comparison ended successfully. This might show for each one of them. Again, as you see, the Dmux 4-way is Nand2tetris successfully. Let's go for 8-way. Oh shit. Oh, okay. I'm sorry. It's 8-way. Yeah. Let's start from the start. Again, since you can see it's loading, compares the value, comparison done. We've done 8-way. Now we'll go for EQ3. Um, okay, so I don't think we have done EQ3 yet. Yeah, sorry. My bad. Uh, I'll do marks. Yes. Again, comparison edit successfully. I'll do 4-way. Now, again, load the script, 4-way, and then compare to CMP file. Check the output, verified. Okay, then go for 8-way. We're done. Now we'll go again for the mux 16 bit. Again, so you can see the comparison is entered successfully. We'll go for not. Load the script for not and click run. Let's compare. Go for not 16. Load the script for not. Compare. Output is verified. Okay. Now we'll go for or we'll go to script again. Or it was over 16. No, it was over. Okay. Compare and output. Yeah. So or is done. Now or wait. Load the script again. Uh, and run the code. Again, successfully done. Just like or 8-way is done, or 16 and XOR are left. I'll just quickly run through it. Compare successfully. The last one, XOR, load script. Again, compare with the compare value. Successfully shown the output. I've already tested this, so we can say we've done it quite well. Okay, so I would just like to conclude by saying that overall, the Nand2tetris software is provides a very powerful set of tools for implementing and testing digital circuits, including various logic gates. By using these tools, we can gain a deeper understanding of how digital circuits work, um, and develop practical skills in digital circuit design and simulation. Thank you.